Next layer is transport layer. The layer below session layer is transport layer. Transport layer contains the reliability of communication through flow control, error control, and segmentation. In segmentation, data received from session layer is divided into small data units called segment. So a transport layer packet is called as segment. Each segment contains source and destination port number and a sequence number. Port number helps to direct each segment to correct application, and sequence number helps to reassemble segments in the correct order to form correct message on the receiver side. In flow control, transport layer controls the amount of data being transmitted. Let's suppose our mobile is connected to a server. Suppose server can transmit data maximum at 100 Mbps and our mobile can process data maximum at 10 Mbps. Now if we are downloading a file from a server, but server starts sending a data at 50 Mbps, which is greater than a rate our mobile can process. So mobile phone with the help of transport layer tells the server slow down data transmission rate up to 10 Mbps so that no data gets lost. Similarly, if server is sending data at 5 Mbps, mobile phone can tell the server to increase data rate up to 10 Mbps so that we can maintain the system performance. Transport layer also helps in error control. If some data does not arrive at destination, transport layer uses ARP request, automatic repeat request, to retransmit the lost and corrupted data. To check the error for the function of the error control, group of bits called checksum are added to each segment by transport layer to find out received corrupted segment. Transport layer protocols are TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. Transport layer does two types of services: connection oriented service, or you can say connection oriented transmission, and connectionless transmission. Connection oriented transmission is done via TCP, while connectionless transmission is done via UDP. UDP is faster than TCP. UDP does not provide feedback, whereas TCP provides feedback. Lost data in UDP cannot be restored because it's not providing feedback, whereas lost data in TCP can be restored because we are getting feedback in TCP. UDP is used where it does not matter whether we have received all data. For example, video streaming, online streaming, movies, songs, games. On the other hand, TCP is used where full data delivery is must. For example, World Wide Web, email, FTP, etc. Next layer is network layer. Transport layer sends data segment to the network layer. Network layer works for the transmission of the received data segment from one computer to another located in different locations. Data units in network layer is called data packets or datagrams. Function of network layer are logical addressing, path determination, and routing. So network layer perform three types of functions: logical addressing, path determination, and routing. IP addressing done in network layer, that's called logical addressing. Every computer in network has unique IP address. Network layer assigns source and destination IP address to each segment to form an IP packet. IP addresses are assigned to ensure each data packet can reach the correct destination. Second is routing. Routing is method to moving data packets from source to destination. Path determination. A computer can be connected to internet server or a computer in a number of ways, choosing a best possible path for data delivery from source to destination. This is called path determination. Layer 3, that is network layer, uses OSPF, Open Shortest Path First, BGP, Border Gateway Protocol, RIP, Routing Information Protocol. Layer 3 uses these three types of protocol, OSPF, BGP, RIP, to find out the shortest path from source to destination. Next layer is data link layer. Data link layer receives data packets from network layer. Data packet contains IP addresses of sender and receiver. So there are two types of addressing, logical addressing and physical addressing. Logical addressing is done at network layer, where sender and receiver's IP addresses are assigned to each segment to form data packets. Physical addressing is done at data link layer, layer 2, where MAC addresses of sender and receivers are assigned to each data packets to form a frame. So in data link layer, divide the stream of bits received from the network layer into manageable data units called frames. MAC address is basically 12-digit alpha character number that is embedded in NIC, Network Interface Card of your computer by your computer manufacturer. Data unit in data link layer is called frame. Data link layer is embedded as software in NIC of a computer and provide means to transfer data from one computer to another via local media. And if we're talking about local media, local media includes copper, optical copper, air, and radio signals. Data link layer performs two types of basic functions. It allows upper layer of the OSI model to assess the media using techniques such as framing. It controls how data is placed and received from the media using technique media access control and error detection. Consider two distant hosts, laptop and desktop, are communicating with each other. As laptop and desktop are connecting to different networks, so they will be using network layer protocol IP for communication with each other. Now the last layer is physical layer. If we conclude it till now, we will conclude data from application layer has been segmented by transport layer, placed into packets by network layer, and framed by data link layer, which is a sequence of zeros and ones. Physical layer converts this binary bits into signals and transmit over local media. It can be an electrical signal in case of copper cable or LAN cable, light signal in case of optical fiber, and radio signal in case of air. So signal generated by physical layer depends on the type of media used to connect two devices. Now, if we will see at the receiver side, at the receiver, physical layer receives signals and convert it into bits and pass it to data link layer as a frame. Frame is further decapsulated as data moves through higher layer. Finally, at the end, data is moved to application layer. Application layer protocol makes the sender message visible in the application in the receiver's computer screen. So in this whole way, OSI model is helping to transfer data between different hosts. So these 7 layers of OSI model are basic or main layers that are lying behind the smooth functioning of internet. I think it's enough for today. In the next class, we will continue with TCP/IP model.